Hello everyone, this is Wahid from University of Oulu. Today I'm going to demonstrate the Kubernetes platform within some simple applications for the FRACTAL project. The agenda for today is to investigate Chemo environment for RISC-V and ARM64 machines. First we will see these platforms alongside with the RISC-V and Docker and Kubernetes platform in it. Then we will cover other applications of the Kubernetes platform. So let's start with the environment first. I'll introduce the Chemo environment for some specific reasons. Chemo is an open source emulator which can run on top of almost any operating system and can provide different hardware architecture regardless of what the host architecture is. Just as some examples, it has the ARC64, which is for ARM 64-bit machines, RISC-V, any 32-bit architecture, and also it supports Xilinx Versal and much more. The installation process is simple. It can be installed using package managers, which we do not recommend it because we do not need all of its components. In this project, for the reason of integrity, we chose to build it from the source code and use version 6.2, which is one of the latest versions at the time of this presentation. A simple configuration for the RISC-V architecture is shown in this slide. The environment is RISC-V64 soft MMU, which will output the Chemo 6 system RISC-V64 binary for us to run with these flags. And the configuration for ARM-based machines is to use ARC64 soft MMU for the environment, in which the Chemo system ARC64 binary will be generated, and other flags to run the machine. As you see here, if we need to emulate the Versal board platform, we can use the Xilinx Versal virt flag for the machine type. However, we have an alternative for the ARM64 based architecture to use NVIDIA Jetson Nano, the 4GB RAM model. As you can see from the specifications of its CPU, it has a quad-core Cortex A57. If we want to introduce some challenges by comparing these two architectures' point of view, I should say that the most of the tools and applications are built for ARM and alongside the AMD architecture, including the Kubernetes and Docker and the necessary tools for them to provide a cluster. So ARM has no challenge in comparison to RISC-V based. Let's see how we can make the Docker and Kubernetes work in RISC-V machine. Okay, so the prerequisite for the Docker service in RISC is Golang. Carlos Eduardo has already built the Go for RISC. You can find the link here and access the repo and build it from the source. And if we want to install Docker in RISC-V, we can build it from the source. We can have the feature of pushing the images to Docker Hub or locally transfer the Docker images. For example, we have built a PostgreSQL image for RISC-V and pushed it in Docker Hub, and you can pull it simply with this command. And for Kubernetes, it is similar to Docker. You can build a modified version of Kubernetes for RISC-V, which is available in this repo. And let's see the demo for RISC and ARM-based machines. Okay, let's see how RISC and ARM environments are working. So first I want to show you the RISC environment in Chemo. So I need to go to its directory. So for the sake of simplicity, I already built a bash script file for that. So as you can see here, our flags, as I already mentioned, are here. Machine virt, CPU, memory, shared the number of cores, and etc. And I intentionally shared some specific ports here. So I shared the port 2222 and map it to SSH port 22, so I can SSH from my host to this machine. And also I shared another port 2221 for other reasons. Okay, so let's run it now. Okay, let's wait a couple of seconds to uh, make sure that the machine is up, and in the top right terminal I will SSH into that machine so I can have two simultaneous terminals to this machine. Okay, I guess it's up now, but what's the problem? Oh, I missed this L here. And let's try to log in into emulated environment too. Okay, so we are in. Now let's see how Docker works. In top right terminal, I just run the simple command of Docker. I already installed the Docker on this RISC-V environment. Oh, before I show you the Docker, I just want to show you the LSCPU output. So as you can see, the CPU architecture for this machine is RISC-V 64, as we set it in the RISC-V flags. So let's go for Docker now. So hello world image. Let's see that it is working. Okay, so in top right, in top left terminal, you can see that the kernel logs are printed. So what's happening in kernel in this emulated environment are in the top left terminal. So okay, so as you can see, our Docker image is running fine, and we have absolutely no problem. And for the sake of simplicity, I built the Kubernetes platform, but let's check that it is working from here. Get node. So I should run the Kubernetes platform here. Let me go to its directory and just install it from here. Okay, let's wait for a couple of seconds. So Kubernetes will be up. The reason that we chose K3s is that it's lightweight and it uses less memory than the other Kubernetes services like MicroK8s and others. So it is a good choice for us to use this instead of other Kubernetes services. Okay, I guess it is up for now. Let's check it here. Okay, as you see here, I already built this Kubernetes node. The reason that you see the age 82 days, it built it 82 days ago, but the service was not started, so I run the install command to make it start. I could do it with systemctl command too, but I choose it this way. Okay, so Docker and Kubernetes are working fine, but let's exit from this environment. And I want to SSH into my other nodes. For example, I have this node for ARC64, I mean ARM-based machines. So as you see, it is using the Cortex A57, and actually it's a Jetson Nano device. So, and here I also have the Docker and Kubernetes. The reason that I don't want to show you the Kubernetes platform on this machine, it is because of that I connected it to bigger clusters, so I have connected it to this cluster. So let's describe this node. So as you can see, my node here, it is local IP address and other stuff. So everything is fine in this environment. So we can move forward with the presentation. Okay, let's move to cover the Kubeflow for this part. So far we have investigated the platforms and required tools. Now let's see what we can do with them. Kubeflow is an open source tool for building machine learning application pipelines. It also provides some other cool machine learning tools such as Jupyter Notebook and etc. Here you can see its architectural design. From the bottom, there are cloud provider services which Kubernetes is on top of them. In the middle layer, Kubeflow configuration and site helper applications are. Here the important components are pipelines, Seldon Core, KF serving, chainer, and other stuff, which are the actual tools for building machine learning applications. And finally, in top layer, the machine learning tools are. So it exposes its capabilities to build these applications. In this slide, you can see more or less a couple of famous machine learning tools which are available in Kubeflow. As an example, you can select between Kserve and Seldon Core for model serving. Even more, we have used MLflow to store the model from Kubeflow pipeline. Here is the example where we have a pipeline in which exist three modules. These modules are pre-processed data, which will pass the data to train model and test model. And we have train model module, so it will start the training the model. And at the end, we have the test module, so it will test the result of the train model and using the data from the pre-processed data module. So let's see the demo for this part. Okay, let's see. Let's go to our cluster. Okay, let's get the nodes first. Okay, this cluster has three nodes, and let's check out the services that are running on this. Let's check out Void. So yep, every necessary system for Kubeflow is running. Knative, Kserve, Kubeflow, and other stuff. And inside of Kubeflow, we have pipelines, we have KF serving, we have Katib, and also Jupyter Notebook. And we shared our cluster. We shared the storage of our cluster with NFS, so we can share the whole directory between the pods. And let's check that directory to make sure that everything is fine. Okay, so this is the directory that has been shared with NFS between the pods. So since our pods are running in different virtual machines and different nodes, so they need to have a central place for storage. So for that reason, I have brought up a NFS server in this machine. So the data here, it can be shared with others. So as you can see, our Kubeflow environment is here. We have the notebooks, which we can connect it to it and check it out to make sure that it's working fine. Here I already used this to build two other pipelines for just some examples, and yep, it is working. As you see, the Python is working fine. Okay, let's go with our pipelines. Here I added the pipelines that I already show you in the slides. So let's create another experiment here. Test 101. We want to run this test run 101, and we choose the pipeline, which is test. Sorry for the naming. Okay, so it is created, and let's see the result of this pipeline. So you will see the output and input here. So it is good, and the pipeline goes to next stage, I mean to next pipeline, and it runs it too, and the last pipeline, which is also fine. I already have another pipeline here, so if I want to show you, it's a simple pipeline, and if I want to show you the result of the pipeline, here we can see its results. So we can see the input and the output of the pipeline. So since this pipeline is just a simple number, so we can see it in this way. So let's go to the next. Now we will cover systems connectivity. For this part, we will introduce MQTT and Kafka, and we will give an approach for connecting MQTT Kafka to MongoDB or PostgreSQL for data preserving. Another example of the system connectivity, we propose some approaches. So let's define the problem here first. Assume that we have an end application which generates data or processes the data or reads sensor information, whatever. So it will not need to send the data to a consumer or receive some data from a producer in this setup. The first approach has a design like this diagram. So the application resides in a node, then it sends or receives the data to or from Mosquito instance and Kafka server. In the end, the consumer or producer can use this data. The benefit of this approach then would be the system scalability. Every instance in this system can be scaled easily. However, the main drawback of this approach is that redundancy in sending or receiving the data between the application and intermediate instances. So what we can do here is that we can make a connection between Kafka and Mosquito so that Kafka can push or pop the data from the message queue, as you can see in this figure. Even more, we can extend this approach so Mosquito can run alongside the application in the same instance for the communication part. It is worth mentioning that we can connect any number of producers or consumers to Mosquito, which it is closer to up now. Okay, but what tool can we use to build this connection between Mosquito and Kafka? Well, there are tools for that to build such bridges between these two. For example, Kafka Connector and MQTT extensions are one such. which are not free and open source. So the methodology here is to implement a connector on our own. We call it MQTT Kafka Bridge for now. But what about the databases? We can take the same approach for them to implement an interface for their connectivity to the cluster. Now let's see the demo and how it works.
Machine. Okay, the next step for okay, and before that, before going through, I think I forget to show you the uh, show you the commands that I use to run this RISC-V machine. So I want to go to that directory to show you the commands. So I already put it in this bash file. So as you see, here is the command that I'm using it to run the RISC-V machine. So I just forget to show you this first. Okay, the next step for me is to show you the connectivity that I already mentioned about. So in the left up left terminal, I will run the Zookeeper. Zookeeper is one of the dependencies that Kafka will use. So this is the command for Zookeeper. Okay, Zookeeper is started. And this is a command for Kafka server, which actually use the Zookeeper to be run. Okay, and I should say that before going forward, I already write a consumer file in the server to show you the data that it will be pushed to Kafka server. So this is the most simple code that you can write for Kafka to show the connectivity and to show that the data is actually coming to the Kafka. So I just run this consumer. Okay, everything is set. Okay, and for the first part to show, I have this application named MQTT. And by the way, the first, I mean, the above terminals are the terminals to my other ARM device. So if I give the LSCPU, okay, as you see, this is the ARM-based device, and also in my bottom terminals, I have the RISC-V. I have the RISC-V architecture. So these are the three different machines. The first machine is running the Kafka, and also this consumer, and my second and third machine is run on ARM machine and RISC-V. Okay, so move forward with the demonstration of MQTT. So a simple application that I had it in mind for showing the connectivity. I already wrote it in Python. I generate some data and I will push it to MQTT. So again, this is the simple. This is the simplest way to generate some data and push it to MQTT. And also, I did the same for RISC-V. So I go to this directory and show you the. Okay, as you see, these are almost same. This is the this is the script to produce the data for MQTT. And then I want to show you the connector, I mean the bridge that we build it for connect MQTT to Kafka. So again, we used Python. In the above machine, which we have the ARM, I want to push the data in Kafka into topic that it has the name of ARM. So it has a very simple function. So it will receive the data from the MQTT, I mean its local MQTT server, and after that it will after it receives the data from MQTT server, it will publish or send it through the Kafka and into this topic that I already mentioned here. I mean to this topic. And also for risk machine, it is the same. So, but the only difference is that the topics are different. So the topic here is risk. Okay. And first, I should run the MQTT to generate the data. And here in the right terminals, I will try to run the bridge, the commands that will send the data to Kafka. And also I will do the same, and I will show you in the other terminals that actually we are receiving the data there. Okay, so everything is receiving and sending the data. Left terminal sending the data to MQTT, and the right terminals are receiving the data from MQTT and then send it to Kafka. And here in the consumer that we have here, you see the data that Kafka is receiving from those connection, I mean the bridges. So as you see, they are from different sources. So the first is test arm, and the second is test risk. And it means that the whole system is working fine. Okay, I just closed this terminal to go forward with the next connectivity that I wanted to show you. Okay, the next thing is that we have, let me check that I have the code here. Okay, I have the code in RISC-V. Okay, the next thing is that we have the connection of Kafka to the Postgres or MongoDB database. So I already wrote the code for that one. And again, I try to write the code as simple as possible. So I defined two functions to show you the different types of communication. So the first function is that it will send data to Kafka. I mean, it will take the data from the database from Postgres and then send it to Kafka. And also the second function, which will wrote a new data which is generated, which is produced from Kafka, and it will write it into the Kafka. Okay, I mean into the Postgres. But before moving forward, I want to show you the database here. So as I already mentioned, we have the Postgres in RISC-V. So I named the database test for now. Okay. I wrote a simple table named weather, and Here is some data that I pushed into this table. So what we want to do here is that we want to pull this data from a database and then send it to Kafka. And here in this terminal, I mean in the bottom left terminal, we want to show you that the Kafka is receiving the data. Okay, so I just run the command. Okay, it just fetched the data and sent it to this. And here, as you see, it received the data from this topic, which the values are different, which shows that this is actually working and taking the real data from the database and sending it to Kafka. And as I mentioned, it's completely bidirectional. I mean, it can be done in other ways. It can receive the data with the consumer that we have here from Kafka and then send it back to the database. And it is not matter that what database we are using. The point is that it can completely communicate with any databases. And if you want a language that is providing us more performance, we can easily use a Scala, for example, or any highly available language. And also here about the Confluent, the company that is building this Apache Kafka approaches for data. I have checked it so far, and the only difference between their solution to to ours and theirs is the language that they are using.
This was a presentation for Kubernetes platform and some approaches for developing a system. Thanks for watching. For more information, you can check out the website or send us email.